Hello everybody, today I will be explaining a few different types of collections in Python. There's 4 general purpose collections, 3 of them are lists, sets, and tuples. There are also dictionaries, but I'll save that for the next topic because they can be kind of tricky. A collection, I would think of them as a single variable, and I'm saying that within quotes, that is used to store multiple values. That's how I would explain a collection to a beginner. For example, let's say we have a variable fruit. Fruit equals some value, like apple. And then I can print this fruit, which is apple. I could turn this variable into a collection by surrounding my values with either a set of square brackets for a list, curly braces for a set, or parentheses for a tuple. Let's begin with the list. If I would like to store more than one value in this variable, I will surround my values with a set of square brackets. This variable is now a list. I can store multiple values separated with a comma. Not only do we have an apple in this variable, but we have an orange, a banana, and coconut. One naming convention that I like to use, if I declare a collection, such as a list, set, or tuple, I like to take the variable name and make it plural, just so that it's more obvious that this is a collection of values. Technically, in the English language, fruit would still be plural. English is a weird language. We now have a list of fruit named fruits. If I were to print my list, this is the result. We have all of our values enclosed with a set of square brackets. To access one of these elements found within your list, you can use the index operator, much like what we can do with strings. The first element would have an index of 0. That would print my value apple. Index of 1 would be my orange. 2 is banana. 3, coconut. What about 4? We don't have a value there. List index out of range. Each value in a collection is also known as an element. If we attempt to access an element that's not found within our collection, you'll run into an index error. With the index operator, you could set a beginning index, an ending index, and a step. I would like the first 3 elements. You could say 0, 3. That would give me apple, orange, banana. Technically, you don't even need the 0. You need that colon, though. We can even use a step. I would like every second element. Apple, banana. It's every second element beginning from index 0. Maybe I would like my fruit backwards. I'll set the step to be -1. Coconut, banana, orange, apple. You can use the index operator with collections, much like you can use with strings. Another cool thing you can do too with collections is that you can iterate over them with the for loop. For x in my collection, fruits. What would we like to do? I will print whatever x is. So we have iterated over our list. Apple, orange, banana, coconut. Now x isn't really too descriptive. What you'll see some people do is that with their collection name, it's plural. Their counter will be the singular version of that word. If our collection name is fruits, let's rename x as fruit, singular. It's not mandatory, but that's a common convention. It's more readable that way. For every fruit in fruits. If this were cars, you could say for car in cars. Our counter is storing whatever value is within our collection. So what are all the different methods that we can use with collections? To list the different methods that are available to a collection, you can use the dir function. Within this function, add your collection, fruits. But we would need to print this. Let's surround this function with a print statement. These are all in alphabetical order. We have attributes, which I have not explained yet, but I will in a future topic. But if we scroll to the end, we have a bunch of different methods that this list can perform. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. If you would like a description of each of these methods, there is a help function. Help, add your collection to the parentheses, then we would need to print this. Here's a description of all the methods and attributes. For example, we have our sort method. And here's a description. Sort the list in ascending order and return none. And then a bunch of other stuff. If you ever forget what you're capable of with a list or other collection, you can always use the help function to print a description of the attributes and methods available. If you need the length of how many elements are within a collection, there is the length function. Return the length of my list fruits, then let's print it. There's 4 elements within my list. The length function returns 4. If I were to add an extra element, like a pineapple, then that number would be 5. Let's remove that. Using the in operator, we can find if a value is within a collection. Is our value apple in fruits? But then we would need to print this. This operator will return a Boolean, so let's print whatever that is. Is apple in fruits? That is true. But is pineapple? Pineapple is not. It's false. You can use the in operator to find if a value is within a list, and that applies for your other collections too. With lists, they're ordered and changeable. Duplicates are okay. We can change one of these values after we create our list. Let's take fruits at index of 0. I will set this equal to be a pineapple. Then let's iterate over our fruit using a for loop. Okay, the first element is no longer an apple, it's a pineapple, then orange, banana, coconut. Using an index, you can reassign one of the values. If I were to change 0 to 1, well, now we have an apple, pineapple, banana, coconut. Let's cover some of the methods that are found within a list. We can append an element. Type the name of the list, dot, append. What would we like to append to the end of this list? Let's append a pineapple. I'm going to get rid of this for loop. I'm just going to display my list. There, we have an apple, an orange, banana, coconut, pineapple. To add an element to the end of a list, use the append method. To remove an element, you can use the remove method. Fruits.remove. Let's remove our apple. Our apple is no longer there. We have an orange, banana, coconut. Using the insert method, we can insert a value at a given index. Fruits.insert. List an index. 0 would be the beginning, then a value. Pineapple. Now we have a pineapple, apple, orange, banana, coconut. The sort method will sort a list. Fruits.sort. These are all in alphabetical order now. Apple, banana, coconut, orange. To reverse a list, you would use the reverse method. Fruits.reverse. Coconut, banana, orange, apple. However, these are not in reverse alphabetical order. These elements are reversed based on the order in which we place them. If you would like reverse alphabetical order, you can first sort and then reverse. Now we have orange, coconut, banana, apple. To clear a list, use the clear method. Fruits.clear. All of the elements are gone. We can return the index of a value. Let's return the index of apple. Fruits.index, list an element. Then we will need to print this. Let's print the index that is returned. The index of apple is 0. Coconut, that would be 3. What if we don't find a value, like a pineapple? Well, we have an error. Pineapple is not in list. You could count the amount of times that a value is found within a list, because duplicates are okay. Fruits.count. Let's count how many bananas are in this list. Banana. Then print it. 1 banana is found within this list. How about pineapples? There are 0. Now, those are lists. Surround your values with a set of square brackets. These values are ordered and changeable. Duplicates are okay. Now let's talk about the next collection, which is a set. To create a set, surround your values instead with a set of curly braces. Our collection of fruits is now a set. A set has different benefits. The values are unordered and immutable, meaning we can't alter these values. However, we can add and remove elements. A set does not include any duplicates. I'm going to delete these methods, then print fruits. We have all of the same values, but they're not in the same order as they were originally. A set is unordered. If I were to run this again, they will likely be in a different order. See, now we have a banana, apple, coconut, orange. To display all of the different attributes and methods of a set, you can use the dir function. And here's all of them. Some of these methods are a little more advanced, but there's a few we might recognize, like add, clear, copy. For an in-depth description of these methods, you can use the help function. Much like what we did before. To find the length of our set, we can use the length function, which is 4. We can use the in operator to find if a value is found within the set. Unfortunately, pineapples are not within our set. Now, if I was to use the index operator of my set, this is what would happen. We have an error. Set object is not subscriptable. We're not able to use indexing on a set because they're unordered, much like what we can do with a list or a string. We can't change the values of a set, but we could add or remove elements. Let's use the add method to add, guess what, a pineapple. That is okay. Orange, apple, pineapple, coconut, banana. We can remove an element, fruits.remove. Let's remove our apple. Our apple is gone, coconut, orange, banana. We can pop. The pop method will remove whatever element is first, but it's going to be random though. Orange, coconut, banana. Apple, coconut, banana. Apple, banana, coconut. You can clear, fruits.clear. The elements of our set are gone. Those are a few of the more useful methods for beginners. As a summary, a set is a collection that is unordered and immutable. You can't change the values, but adding and removing elements is okay. No duplicates are allowed. Let's try that real quick. I'm going to add a second coconut. Yeah, see, we only still have one coconut. Sets may work well if you're working with constants. Maybe colors, for example. You need to find if a color is within a set. Alright, now lastly, let's talk about tuples. A tuple is a collection that is surrounded with a set of parentheses. Tuples are ordered and unchangeable. Duplicates are okay. One benefit of a tuple over a list is that tuples are faster than lists. If you're working with a collection, and it's okay if the collection is ordered and unchangeable, you might as well use a tuple because it's faster. When I print our tuple, all of these values are surrounded with a set of parentheses. Again, we have the dir function to display the attributes and methods. There's not as many for a tuple for methods. We only have count and index. Again, there's also help to display a description of these attributes and methods. You can find the length of a tuple with the length function. We have 5 elements within here. Using the in operator, we can find if a value is found within our tuple. Our pineapple is not within our fruits. So there's only 2 methods we have access to. Let's find the index of apple. Fruits.index apple. Then I will print whatever is returned. Apple is found at index 0. There's also count. Fruits.count. How many coconuts are found within our tuple fruits? Count the coconuts. Then print this. How many coconuts? We have 2 coconuts. And then again, with any of these collections, they're iterable, so you can iterate over them using a for loop. For fruit in fruits. Yep, apple, orange, banana, coconut, coconut. All right, everybody, so those are collections. Think of them as a single variable used to store multiple values. There's 4 general purpose collections for beginners: lists, sets, tuples, and then dictionaries, which we'll talk about next. Each of them has unique benefits. Lists are ordered and changeable. Duplicates are okay. A set is unordered and immutable, but adding and removing elements is okay. No duplicates allowed. A tuple is ordered and unchangeable. Duplicates are okay, and they are faster than lists. Use tuples if you can over a list. But yeah, those are a few collections in Python.